Okay, well, welcome everyone. Thank you for joining today's Craft Brewers Forum focused on optimizing water use. I'm Crystal Sheasley, Program Manager at the University of Maryland Environmental Finance Center, where I help coordinate our Sustainable Breweries program. And we are really pleased to be co-hosting this event along with our partner Green Brewing Programs at the University of North Carolina and University of Southern Maine. And you'll hear from my colleagues there, Justin Nolan and Luke Truman, a little bit later in the session. Can anyone see, is this actually recording? I'm not seeing does it look like it's recording?
100% recording.
It is recording, yep.
Excellent, thank you. Before we got too far. So I want to share just a couple of quick notes before we jump in. We are recording the session so that we can share it out afterwards. And during our time today, we're going to first hear from a set of panelists, and Justin will introduce everyone in just a minute. And then after the presentations, we'll have some time for questions, and we hope to hear from all of you, your thoughts, questions, ideas. If you want to share anything about what you're doing in the area of reducing water use, we'd love to hear from you. But if you have questions during the panel presentations, feel free to use the chat box and pop your questions in there, and we'll collect them and then get to them at the end. And just feel free to send me a message along the way if you have any questions as we go. And I will hand it to Justin to introduce our panelists.
Thanks, Crystal. So as she mentioned, our programs have been working with brewers from all over our regions, trying to reduce source reduction, trying to create source reduction, using less resources, and ultimately saving breweries money if possible in the process. We kind of joined forces on this to plan this event on reducing water and specifically protecting water resources. And we're really stoked about the people that have come to join us today. To just briefly highlight some of the things that they've done to optimize water use or protect local watersheds. So today you'll be hearing from Dan Weber from Dogfish Head in Milton, Delaware. Dano Ferons from Mole Brewing in Wilmington, North Carolina. Franklin Winslow from Tarboro Brewing in Tarboro, North Carolina, unsurprisingly. And Paul Upham and Eric Dumais from Bissell Brothers Brewing Company in Portland, Maine. So we'll just go ahead and start with Dan, if that works.
That's good. So to introduce myself, I'm Dan Weber. I've been at Dogfish for 12 years now. I'm assistant brewing manager, so I've done pretty much everything there. I was a brewer, a supervisor, ran R&D for a little while. So, I've been there a long time and I've seen a lot of different things, especially with our water system. So jump ahead. So one thing kind of unique to Dogfish Head, there isn't a lot of breweries out there operating on well water. And our well is very good soft water for brewing. It's low pH. It's great water for brewing. However, it is high in iron. So we need to go through green sand filters to take that iron out. It's just some pictures of what we have here at the brewery. So that's chlorine adjusted to filter out the iron. And then we're supplying the cold liquor tank, which supplies the hot liquor tank, just pretty much nonstop all day long at 200 gallons a minute. And we have a giant wastewater facility here at Dogfish Head. This is really important to us because until recently, we were actually hauling our own water away. So treating this using the minimum possible amount is incredibly important to us. We have a large bioreactor, which you can see on the left, and then it goes through filtration devices, which you see on the right. And we used to have to haul that away on tanker trucks and put it into fields. So we were actually, trying for years and years and years to use, the least possible amount of water. We just had some upgrades in the town, and now they're able to take our wastewater, which is great. We do, we have pretty good clean wastewater going out. So we're happy with the way the system operates right now. We're happy with the town being able to take it. So those are some sort of unique challenges we have here in Milton, Delaware. Everyone's going to have their own sort of challenges along the way, but just to sort of point out where we're starting here. So to jump right in, my talk's a little bit technical here, but anatomy of a tank CIP, like where are the opportunities to actually save water. So you start in with a pre-rinse, and then a blow off to get the CO2 out. So the opportunities along the way here are really the rinse steps. So you're talking about a pre-rinse, you're talking about a post-caustic rinse, you're talking about a post-acid rinse if you're doing the acid cycle. And so all of these rinse steps are really the opportunity you're talking about to save water. And in between, you're talking about using spent caustic on most of our automated CIPs, which is great. So you can use caustic that you've already used, and then if you can get all the solids out on these first few rinses and blow-offs, then you can reuse the bulk caustic tank and just use that caustic all the time, which is an awesome water savings. So the other thing to think about is which types of CIPs you should be running on each tank. Does it need a blowdown? Are you going to be just running acid sani on a bright tank? Then you don't need any caustic, you don't need any blowdown. So those are the kind of things that you really need to think about when you're thinking about water savings: is what type of tank is this? What type of brand did it have in it? And what type of CIP does it actually need at this point? Because the different types of CIPs are going to use different amounts of water. So, we have fully automated systems here at Dogfish Head. So you're talking about, I pulled up just a random program so you can see it's in a rinse step. It's got a timer and a gallon amount associated with that. But really what I want to get to here is to point out that, all of these gallon amounts have been figured out by hand. Just because we have these fully automated CIPs doesn't mean that we haven't put in the work to figure out exactly how many gallons it takes to rinse each tank. And those are the sort of things that you need to, sort of think about along the way. So this is another screenshot of a CIP skid that we have in the brewery here. So you can see we have bulk caustic and acid tanks. We also have these smaller sort of spent chemical tanks that can be used as rinses. And then coming back on the return side, we have temperature sensor, connectivity sensor, make sure you have flow, and then turbidity also, so you can check how many solids are coming back. So a lot of these are just to help figure out if a rinse is complete, or we do have options even on these fully automatic CIPs to rinse it again if you're still seeing solids. So a lot of these, we're giving ourselves an option to use less water. We also have separate programs for different brands. And I think that's really important when you're talking about water savings. Is, if this was a Pilsner, for instance, that you had in this tank, there's not going to be a lot of solids in it to start with. But if it's a double dry hop, double IPA, yeah, you're talking about tons of solids that you're going to need to deal with. So these different types of brands really need to be thought about as different CIPs to start with. So really just sort of my tips. I didn't want to take a whole lot of time here. We can get into questions later, but the big message from me is that automation, it adds to your consistency, but really the work of figuring out the rinses and the brand to brand differences and the push outs and all that, it has to be done by you. And, you're talking about, you measure your push outs with whatever you have, it could be a difference in pH. It could be a difference in connectivity. It could even be temperature. If you're pushing out a line with hot water, that your push out is complete when the hose gets hot. It can be as simple as that. And then if you're talking about that, you're talking about tracking how many gallons that is every single time and putting that into the SOP and using that exact same amount every single time. If you're not seeing things get clean using the same amount, the same system every single time, then, my other tip would be something else is likely wrong. Are you talking about a clogged spray ball in the tank? Is it not rinsing correctly? Is there a pump issue? Is there some other malfunction along the way? And that's really my tips for saving water. We can jump into questions later.
Fantastic. All right, moving right along. We can jump over to Dano from Mad Mole. if he's ready.
Yeah. Hey everybody, how's it going? So I'm Dano. I run Mole Brewing. We're just like a smaller 7-barrel system. We have some barrel tanks too. So our kind of the footprint that we take here is anything we can do to save some money is good for us. So if we can go to the next one. So kind of like Dan was saying, we look at all of our CIPs. Everything is very much dictated by water use. For the most part, we're not able to measure the gallons or things like that. So we rely heavily on pH test strips and just kind of whether or not the water coming out is hot, and just really kind of focusing on how we're doing it. And then our bright tanks, we keep them under pressure, and when we clean them, we'll do an acid cycle with acetic, keep everything under pressure. But once a month, we'll break the tanks open, run caustic, really look inside, clean every little bit. And then instead of running a CO2 purge, we'll fill the whole bright tank with water and then push that water back out with CO2. And when we're pushing that water back out, we just push it straight into our HLT, recapture that water. So we're minimizing any waste we have. And then our keg washer itself runs just the research, all the chemicals, and then has its rinses, which is really helpful. But I mean, that's kind of things that a lot of breweries are able to do and follow. I know the other things we do are pretty unique for us. So the first one is when the owners opened up Madmole. We can go to the next slide. They put in these Mueller serving tanks. And if you haven't heard of them, I think they're Dutch built. They're really cool. There's a bag inside of each tank. And so we have 10 hectoliter tanks. And so it'll hold about 9 barrels. And what we'll do is put a bag in and then fill the whole Mueller up. And then when the beer sits in there, when the Mueller's done and we're getting rid of the bag, all you have to do, pull the bag out, put a new bag in, and then that's it for CIP. So when we go clean them, there's no water use, there's no like turning over those tanks. It's about 30 minutes to turn a tank over. The other really nice thing to do with them is we make a lot of hazies, and when we make our hazies, we pretty much pull the bag out, put a fresh bag in. But with our lagers and pilsners and things like that, we'll just re-top up that bag a couple times over a year, and then after about a year, we'll let the whole beer drain out, swap it, put a new bag in. So we're kind of saving on the resource that we have. And I know that the company Mueller said that they have guys in Europe who will keep a bag in for like 3-4 years, and they're totally fine. But we just try and keep it to a year, make sure we refresh it with any of our clear beers. Go to the next one. So the other thing that we really focus on is kind of making local partnerships and with environmental groups. So I focus a lot on just in terms of not just water side things. We've set up a malt recycling program. We recycle PackTex. We just try and do anything we can to minimize our waste. But the best way I found through that is we partnered with UNCW, which is the local university. And I offered an internship program that we've had for 2.5 years now. And basically, bringing the students in has been an absolute blessing for us, because for a while, we had our tube, we just sent it down the drain because that's just what we could do with it. I had tried to set up a compost program, local gardening club, but it just wasn't getting off the ground. And so our intern last fall just came in, and I was like, hey, here's a problem. Let's try and figure it out. And she was able to find the Wilmington Compost Company, and we're able to side stream all of our compost, any sort of shrub, spent hops we give to them, and they take care of it, pulls it out of the sewage. Less rinsing tanks, and we'll just kind of give that to them, and we don't have to worry about it. The other thing we've done is one of our interns would notice that we just kind of got in the habit of hosing the floors down at the end of the day, and she just was like, "Hey, why don't you sweep?" And it was just a comment. She just had noticed us always kind of like washing stuff down, squeeing, and she's like, "Why don't you just let it dry overnight and sweep?" And so we instantly like started doing that, and it was just kind of a quick, easy thing. Yeah, it takes 5 minutes to sweep in the morning, and so any hops that fell on the ground from dry hopping or just like dust and things, we just are able to sweep it up. And the other thing that's been really nice about that program is that we have a lot of different people coming through with different backgrounds, and they kind of get they take a different look at the approaches we're doing, and we're always kind of open to anything we can do to help minimize our waste or improve our sustainability. We're, as long as it doesn't take up too much of our time, we're very open to any ideas that they have. We've done partners with local nonprofits. And then the last thing we've been doing is I've been having an ongoing research project with a couple of my interns and one of the local professors, looking at utilizing spent grain, hot side trub and cold side trub in the wastewater treatment process in later stages. So not that initial where it's really bad for the wastewater treatment, but actually adding it to later processes, and instead of using chemicals and things for flocculation. So that's been something that we've been really enjoying. So the last slide. Kind of the last thing is that people don't always think about when looking at brewery water is water that's never actually used within the brewery. So one of the things that we've done is we live right next to a pretty polluted creek. We're right on the coast here in Wilmington. So stormwater is a big thing all summer long. We get massive pop-up storms, hurricanes. So any sort of runoff we have just runs straight into the ocean. So any non-permeable pavement, any non-permeable structures that we have are just kind of a way for water to just grab all the oils and everything right off our pavement and off the roof and just run it straight into Bradley Creek right next door. So we've taken the time to really look at that. And the first thing we did was we applied for and got a US EPA 319 grant. So it's federal grant offered throughout the country. Every state has access to it. And basically what it is it's looking at watershed restoration through stormwater mitigation. And it's a matching grant. So if you get awarded $10,000, they expect you to put up $10,000. But for that, like the $10,000 could be education outreach or employees' time. So you can pay for it not just with cash value, you can get evaluation. And the way you kind of do that is you partner up with an environmental nonprofit, and they're the ones that apply on your behalf. So we partnered with the North Carolina Coastal Federation, and they applied and got the grant for us. So I think this fall, we're going to be putting in 4 parking spaces worth of permeable pavers and a strip at the end of the parking lot. So that'll absorb that first inch of rainwater and stormwater. And then the other thing that we've done a lot of is looking at just what is on the land around us. And so like our entire beer garden is gravel. We have a sump pump underneath it that pumps the water out. There's trees. We put in raised beds and planters to try and catch some of that rainfall. And then I know the intern I have starting this fall, her entire project will be to be putting in rain basins and a couple rain gardens to help kind of slow that initial stormwater runoff. Just even though it's not within the brewery itself, it's really nice to kind of see how we can help outside. Cool. That's it. So, yeah, thank you.
Thank you so much, Dano. That was great. We're gonna segue over to Franklin Winslow from Tarboro Brewing.
So as Justin said, I'm Franklin Winslow from Tarboro Brewing Company. I guess I come to this. We're a small brewery in Eastern North Carolina, and I'm one of the owners and the head brewer there. But I come to water and wastewater from Yards Brewing Company, was where I got first involved with that, and that is up in Philadelphia. And we were making pretty close to 50,000 barrels a year by the time I left. And obviously, the city of Philadelphia, the water department there, had a lot of opinions about exactly what we were doing. And as we grew from about 9,000 barrels up to that, a lot changed along the way, and we had to adapt a lot. So, but you can go to the next slide. So, Tarboro Brewing Company, as I said, we're just a small production brewery, and we do have a tap room in Eastern North Carolina. We're only making about 700 barrels a year, but the water consumption ends up being a fair amount. Over the last 5 years, we've been somewhere between 200,000 to 300,000 gallons a year. And that includes both the production facility and all the tap rooms. And I noted the bathrooms are included in there too, because as we'll see from one of the slides, it has a fairly big bearing on our total usage. And that, that's certainly something not just production wise that you can be considering when you're looking at these things. So the next stat there, 13 gallons of water per gallon of beer, seems like a lot, but the stat right underneath that, 5.5 gallons of water per gallon of beer is what we're doing production wise. I think correct me if I'm wrong, but I think the Brewers Association has said the average these days is about 7 gallons of water per gallon of beer. So, obviously you want to, if you're not tracking that number in some fashion, I really encourage folks to take a couple minutes to at least figure that out for yourself, because if nothing else, it'll show you where you are on that. And while that 13 gallons per gallon of beer numbers sort of, scary when I first looked at it years and years ago, when you stop and consider everything that's going into it, it really changes things. And then the last thing I've got there is the Tar River. That's our source of water. And when I was a kid growing up here in Tarboro, before I moved up to Philly, the Tar River was fairly polluted. And it was always a thought of mine that if any brewery that was going to be here needed to pay close attention to the water quality coming in, but also what we were doing going back out. And so we actually donate the portion of proceeds from one of our beers specifically to the Sound Rivers organization that monitors both the Neuse and the Tar Pamlico rivers in our regions, just because at the very least they're going to catch changes and things along the way, and they're also going to help to ensure that we don't have to do as much upstream to maintain our water coming in. But next slide. So we're a small brewery. I wasn't sure how much folks would know, and I figured I'd go way back and make sure everybody was thinking about these things. Our two main concerns are obviously the incoming water and our outgoing waste. This slide's mainly here to remind me, in hindsight, if I'd been able to break out the number of accounts, having one for the tap room and one for our production brewery, that might have made a lot of things a lot easier. But we didn't. As we set things up, we just got the 1 2-inch main coming off the line. And, all of our sampling and anything for wastewater is also going down the same. So we do have to keep those things in mind. I will also say about sampling on the wastewater side, make sure you are in tight with your water utility from the get-go, and, in working with them closely, because just where they choose to sample and the frequency with which they're sampling can really affect the options that you have at your disposal for mitigating some of those costs downstream. But that's about it for what we're going to talk about on wastewater, just because everybody's stuff is so different. So for incoming water, you've heard it all throughout the day, and you're probably gonna hear it some more. But if you're not measuring it or at least keeping track of it, how are you going to be able to control it? And if you don't standardize your usage in some way, then you won't be able to take actionable measures to correct for that in the long term. So, I list a couple of them. Flow meters. We use a flow meter here on our brew house at Tarboro Brewing, and it just monitors any of the processed water and hot liquor water coming in for us. Totalizes that so I can look at the end of a process and record that. But if you don't have those things, sight glass on your tank, monitoring that, or even just drawing a line on a CIP vessel gives you at least some kind of a reference. And I had some people complaining to me at one point that I was speaking with about, well, you guys are huge. What are we going to do to, make something with our 3-barrel tanks? And I don't even know what my flow rate is. Well, that's easy. Grab yourself a 5-gallon bucket and, run that hose into your bucket and measure how long it takes. And there you've got your flow rate from that hose. So you can calculate from there, moving forward. So it doesn't have to be anything all that fancy, as long as you create some sort of a way to track it or a metric for yourself. And the last one there, if you do have a water utility bill, that's a real easy one. At the end of each month and at the end of the year, you can sort of totalize everything up. And then on those SOP side, obviously, you got to have an SOP. It's good to make sure that SOP is working. I think, as a lot of people have pointed out already, measuring your pH or your conductivity or other aspects of it as it's coming through are a great way to know that you're done rinsing or that you finish that cycle. And if you're going to find ways to reduce that, rinse water volume or whatever, make sure that you're doing it and that it's working when you're done. And then lastly, it's embarrassing, but if you do update that SOP and you find that one of your brewers has not come along and joined the rest of the team, that's going to throw all your numbers off. So make sure that everybody who's doing any of this stuff is on the same page. I know it sounds real simple, but it's easy to forget some of these things from time to time. And when you find out that someone else is still dumping, 5 barrels of water down the drain that no one else is doing, and been throwing your numbers for 2 months, then it means all of that data you've collected is suddenly irrelevant. Next slide. So, like I said, it's easy to do. It can be part of your SOP process. We like to track it in our cleaning logs. And if you don't have a cleaning log, you should. I think there are some regulatory agencies that have opinions about that. But if for nothing else, as other speakers have already said, the knowing what was in that tank and what sort of process was done on that tank to clean it can really help you in the long term. I think it was Dan was saying, the difference between a Pilsner and an IPA for your CIP may be very different, and it's definitely going to affect how you adjust in the long term. And then that water utility bill it's huge. We actually go through and actually track those things. Just throw it into a spreadsheet and look at it year over year. And we set little goals for ourselves, but it's been crucial in finding some issues along the way. Now, I did list finding leaks the hard way in here. This wasn't here, though it has been useful in finding some ways that we could reduce and actually seeing that we had effectively cut down on it. But I have a story of a friend who's there was a water pipe that burst under their pad of concrete, and it's high density concrete, so there was no way they were going to notice that for quite a while. And the only thing that happened is someone could hear something funny with the water, but then they also got that first water bill, and it was different enough that they took notice of it. And if they hadn't been paying attention to it, it might have just gone through the pile and been paid. But they saw that and started looking into it. And sure enough, before it became a major issue, they corrected the problem. And then obviously, if you're reporting somebody, the bean counters may have opinions about, whether it's worthwhile to take these steps. But certainly putting a cost comparison on some of these things just to show what your savings may be can really provide a little more of an argument in your favor for any of these programs. And this is just an example I laid out. Obviously, do it as you see fit, but we track the usage water in gallons. And as you can see, this is in 2020. And we calculate the amount of barrels produced over that same month period of time. And we're also, the way we're doing this, we're including both brew house production as well as package production, not just the volume that goes out the door. Because we're tracking, those are the steps that are using the most water. So we want to keep an idea of, sort of apples to apples comparison, but set it up as you see fit. You just know that you may be like a month off if you're tracking it in one way or another. And then, as I said at the beginning, that water, gallons per barrel or gallons per gallon, however you want to do it, can be important. And as for a couple of examples, if you look at May there, you'll notice that our numbers drop way down. Well, if everybody remembers COVID in 2020, all the tap rooms and everything closed, and suddenly we were only making about 5,000 gallons of water go down that drain or come into the facility. And that was kind of eye-opening to see that just sort of shutting down the tap room and limiting our bathroom usage, particularly, had that drastic an effect on our total number. It really made me go back and look at take a more careful look at what our production usage levels were. And then if you look at the month right after that, you'll notice it's through the roof. That may still be the largest single month usage that we ever had. And at first we tried to argue that it was, we had to, change and do a whole lot more canning and transition a lot of beers into package that were, would normally have been draft, but it couldn't explain for that. And then we went back and looked at it, and some person pointed out, well, wait, isn't that the month that somebody forgot to shut off the fill valve on the hot liquor tank and it was overflowing for several hours? And sure enough, then and there we had an argument for why didn't we put an automatic float valve to shut off the hot liquor tank fill. So it's those kinds of things, finding going back, and you have to measure it to be able to figure out that something's gone wrong, and then it's knowing what that cost you to see, well, how would it be worth it to to make some changes going forward. And then these are just some simple basics. If you're not burst rinsing or don't have a way to do something comparable, I highly recommend it. As a small brewery, 3 30-second burst rinses work great for us. And that's, you don't need any fancy equipment for that. You can count it in your head or with your pocket watch. But certainly you can, start at a longer rinse time and reduce as need be. But just make sure that it's, working for you. We looked at other ways to minimize our wash down volume, including capturing some of that rinse water some of the other folks are doing. Or as one brewer started doing, he would do the first 2 rinses, and once everything was pretty much clean and he didn't have to worry about it, he would actually take the hose off the tank out of the drain and then use that as the water was just flowing out, to clean the pad and get all the yeast and hops and everything off out from under the fermenters. And then the rest of these are things that other people I think have touched on as well. Washing down at the end of a process, reusing bright tanks, and cleaning under pressure. They all make a lot of sense. But really tracking the little things and say knowing and understanding what's going into your tanks is really huge. I pointed out to someone that for the cost of added time and rinse water and caustic, that if they just put a defoaming agent into one of their beers, it would cut down on the amount of trub left on the amount of soil left on the inside of the tank. And that volume, that cost was less than the cost of the water itself. But without measuring it, you have no way to know for yourself. So I think that covers it.
Right on. Thanks, Franklin. Yeah, I think we're in the back of the line, so we're probably going to be covering a lot of stuff that a lot of these great panelists have talked about so far. But yeah, the first thing we'll kind of go into, you can do the next slide, Crystal, is our partnership with our local watershed. Sebago Clean Waters is an organization that works to protect the Sebago watershed, which is actually it's only 1 in 50 in the entire country that is a surface water supply that does not require filtration. So we are incredibly lucky to have it. It's a very beautiful water source. We don't have to do any sort of pre-treatment at the brewery or filtering. So again, just very fortunate to have it. It is excellent brewing water, excellent drinking water. I don't like traveling because I love drinking the water we have. But as a company, we have really dedicated a lot of resources and made a strong step for years now that we believe in this and we support this. And I think a lot of the other panelists have kind of had similar ideas as well. But we have donations coming from a co-branded Nalgene that we sell here. I believe $5 from every one of those goes to the organization. And then this January, we released a non-alcoholic hop water, and 5% of those can sales goes there for now until the end of time. Hopefully that's a product that we always have. But yeah, just showing that as a company, we believe in protecting water as a resource. And this is one of the, steps that we really believe in overall. You want to talk on this one?
Yeah, so this it's surprising hasn't really been touched on yet, which is kind of nice. But one of the things that we do is collect all of our spent chemicals. So it's as you can see in the slide, it's nothing fancy. We just have a tote next to our brew house, and it takes all of our spent chemicals that naturally sort of neutralize themselves. And we just collect those before sending them down the drain. We do a pH check and then adjust between 5 and 9, which is what's required from the city. But yeah, we just have inline next to our hot water and cold water drops. We just have another wastewater drop, so it's just hooked right up from the tanks. Doesn't require any more effort from the staff, and that's one of the things that we find to be easiest to help people adopt. If we can make it simple and just becomes a natural part of the process, the crew just kind of naturally starts to do these things. But yeah, it's nothing high tech. We've been doing it kind of from the beginning, but yeah.
Yeah, it's something we've invested in over time too. This started with just using like a simple IBC that was just kind of off to the side. You had to run a longer hose to it. Things that maybe aren't convenient, but it's, you know, a good thing to do for the municipality. And as time went on and we had more resources to invest in like hard piping things, that's where we, you know, really dedicated. That way there's no more hose going across the floor where another staff member might be coming and going. We produce about 13,000 barrels a year in 11,000 square feet. So we're very dense. So hoses on the floor, there better be a very good reason for it. So we're really trying to, you know, keep processes from impacting each other, if you will.
And I think a lot of kind of panelists have touched on it without saying it, and what we do here is the proof of concept. Not everyone, especially even your staff, are going to care as much as we want them to necessarily about certain things. But if we can prove, just like the benchmark tracking, like this is helping us save water, this helps us save money. And like we did proof of concept, like Paul said, with the IBC, and then how we can then invest and why it makes it easier, and convincing the powers that be that it's money worth spending.
Yeah. I took pictures out of it before we start diving into bright tank work. Just talking about side streaming a bit more that some of the others have spoken about. We do side stream all of our spent hops and yeast as well. And that was another one where we kind of invested in like one central pathway. We have a 2-inch stainless line where all the trub from every tank gets pumped out of there into IBCs that goes out for composting. So we have about, I think, 18 now that are stored outside that get picked up every other week. That goes to a digester. Yeah, it's just another one of those things that one is a cost. That's a hard thing for certain businesses to swallow, that like if your municipality is okay with you dumping those down the drain, then you're going to be hard pressed to spend the money to side stream it. In Portland, we have to side stream it. So it's one that it's just normal to us, but it is a good thing to have that close relationship with your municipality and kind of work with them and show them that you want to like work on the issue together. You don't want to just be battling them and trying to skirt the rules. But yeah, we'll kind of talk about some kind of low tech water conservation strategies that we have here. A lot of these are really just kind of things that we've learned through COVID, honestly. And some of them were born out of, you know, the CO2 shortages that we experienced here. I'm sure some of you experienced similar things, but it came down to like, how do we use less gas overall? How do we not run into an issue where we're going to not have the CO2 we need to operate and carbonate beer? So that came down to tank purging. So can we afford to keep our tanks under pressure for enough time and like not open them up and do a full alkaline and a repurge? So we upped our usage to we do 6 cycles total before we open them up, as long as the brands allow it. So as long as it's the same yeast. And generally, if we're going from like a light colored beer to a dark colored beer, we will tear it down and do an alkaline, even if the yeast is the same. But it's just those considerations. But you know, the kind of The tail end of that habit change, we started to notice like water savings through that just by not having the thermal change of heating a tank for an alkaline cycle. So just what we've seen in general for us, it takes about 90 gallons of water to do an acid under pressure cycle on a 60-barrel tank. That same cycle on the same 60-barrel tank will take 320 gallons. So a pretty significant increase, you know, and we'd like to think that we're pretty tight with our operations in terms of like water usage and how our staff is optimizing it. But even with that, just the amount of water just to heat and cool the tank between those processes was really pretty significant. But yeah, you know, all that adds up to about a 12,000 gallon savings annually if we can cut down on even one alkaline a week. So all in all, it's just to say, just kind of challenge what you're used to doing, what you think is right for the beer, like validate it, come up with new processes, test it. You know, even if it's for us, what we were doing is like, all right, it's been 4 fills since we've opened this up. Let's open it up right now and look at it and just really see if this is something we're comfortable with. Does the stone look okay? Are the ports still in good shape? Is there beer stone that is like building in here or not? Things like that. And yeah, you can generally see some pretty positive results if you kind of push your beliefs in that way.
All right, Luke, is gonna come on now and gonna ask a few questions for our panel. We invite also questions from the audience.
Yeah, so I'm thank you, Justin, and thank you, panelists, for all of your words. Like, very awesome, very good work. Before I kick off with questions that I have, you know, this is put on for the Brewers. So any attendees, any questions that you have, take priority over my questions. So we've got some cool stories in the chat. But I would say just go ahead and unmute yourselves and speak right up.
Yeah, and Travis, you put something in the chat. If you could just voice that question, maybe.
Yeah, hi, can you hear me?
Yep.
The company I work for, we make filters, and we were part of this Atlas Copco project that helped Widmer Brothers Brewery to have a dry vacuum system instead of a wet vacuum system. I'm not really familiar. It's kind of like a new thing where I'm not really familiar if smaller breweries are focusing on focusing on foam reduction.
Let's have any thoughts on that question? I guess, Dan, do you guys do much work with foam reduction?
We've actually been getting away from anti-foam, mostly as just a preference of not putting the oil into the product. But I mean, there are a lot of different things you can do to get away from foaming. You know, you can slow down your fermentation in general. You don't need to add the antifoam. A lot of products you do need to add the antifoam in, just depending on how aggressive that particular yeast is and how top heavy the foam cap is. Certain yeasts build a lot more foam on the top. I could think of Widmer Brothers as a great example of that. You know, with the Belgian strain, that's going to be very top heavy in foam. Other yeast strains are not going to have that foaming problem. So there's a lot of different things you can do to look at your foaming problems, and whether it's a problem in the first place. But yeah, I mean, I think I come from a smaller brewery before. I think a lot of people are heavy into using anti-foam. I do think there may be a small portion of people that are overusing antifoam. But like was discussed earlier, there are a lot of benefits to keeping that down, especially with having to clean it out later on.
Yeah, good point. Thanks for that. Yeah, and thanks for that question, Travis.
I can
Anybody?
say,
Yeah,
I
go ahead.
got one other one. Yeah. So I know we used to use a silicone-based defoamer, and I never really liked it because I felt like it carried through to the product. And the old brewer we had before me used way too much. So we recently switched over to, I think I did it last year, to it's like a oil. It's like basically Crisco. It's an all natural like oil that the yeast actually will break it down. So we did it on our small batch system a few times, and we don't get any of it after about 5 days in the fermenter. So we'll add it as a foam cap to our boil kettle, and then by time 5 days through the primary fermentation, everything settling down, it's completely broken down by the yeast and gone. So ever since we used that, we don't have any foam over issues or anything anymore. So you just kind of keep to that.
I would echo what Dan just said, especially in fermentations. We've been adding a similar product. I think it's the Bertco Patco 360 or 376. Yeah. We we have a couple of our beers that are filling up our tanks, possibly to a point where if high fermentation, you're going to start to see some stuff coming out CIP, which is obviously never a good thing. But that has mitigated that, and it has also cut down drastically on the amount of soil left on the tank. So the Kreuzen line is much smaller, and it's much easier to clean the tanks afterward. So just for water savings, it paid for itself, but also in beer savings too. I'll also say I'm not familiar with the dry vacuum methodology. So, we're relatively small, so maybe something being used elsewhere.
I think from what I understand, that's a way of sucking the CO2 out rather than blowing it out. It's just a different way to blow down your tank, basically.
So Dan, I will start with you with a question, and any of the attendees, please just feel free to interrupt me or ask any follow-ups. I was curious. So your wastewater treatment system, you were saying you have bioreactors. Is that an anaerobic system?
Yeah, we have a fully anaerobic system. We added a small aerobic system later on because we were finding that we weren't able to clean up the water as much as originally expected. And so the original goal was to, bring this water back into the building, into hose drops and things like that. And what we were seeing was that it still had an odor, it still had an appearance, things like that. So we ended up having to add more equipment down the road to get where we are today. But we're very happy to, be able to send this to the city at this point.
Nice. Yeah. And are you recovering the methane that you're producing and actually using it in the facility?
Yeah, we have a constant, methane flame going off the side of it. And it can run a generator if we so desire.
Okay.
One interesting thing, we were talking, Trube earlier. Not everyone's going to be in the same situation with Trube and whatnot going down the drain. We originally designed the brew house to take all of the Trube into the spent grain. That was the way that GEA designed the brew house. It was working great. And then we eventually got to the point where the reactor needed more nutrients down the drain. So we actually send our Trube down the drain now to the reactor. So it's just it's a scenario where, you're never really going to know what you have until you're doing it. Because that was something we certainly did not expect.
Are you producing now enough nutrients, or have you considered taking stuff from other breweries as well?
The Trube has helped a lot.
Yeah.
And we're now, this was more, we're talking 2020, 2021 when production was down. Now that we're more fully producing, it's not as much of an issue.
Nice. And you were saying with your bright tanks that you'll what, once a month tear them down to make sure everything's kosher on the inside. Is that like, what kind of data is driving that decision? Is it just out of caution? What are you seeing when you do crack into them?
It is really out of an abundance of caution. Filtered brands, when you're talking 60-minute, 90-minute, those brands will go direct back into with no cleaning. Other brands will go into with just acid sani for weeks at a time. But the once a week caustic is really a precautionary thing. We don't have the ability to look inside of our bright tanks. That's one difference of our scale versus some of the other places where you can just take a flashlight inside. So every once in a while you just have to do caustic. That's part of the game.
Nice. Yeah, and I guess Dano, to throw the same question at you, as far as when you decide to tear your bright tanks down, is that out of caution, or what are you seeing when you crack into them?
Mainly out of caution. Just for the most part, that acid cycle rinses everything really, really well. And we've been experimenting with the main acid we use is heavy on the phosphoric. It's phosphoric with a little bit of nitric. But we've been experimenting with a nitric acid plus a detergent blend as a cleaning cycle. It's what we use for our keg washer, and it leaves everything spotless. So we've been experimenting with that to see if we can actually just forego on the caustic cycle for longer. But it's more just every time we open up the bright tank, it's always spotless. And it just, I don't know. I get nervous. I'm like, we're just gonna kill everything. Run the hot. I don't care. So it's kind of more that caution, just not wanting to have bad product end up down the line.
Yeah, that makes sense.
We also don't have the ability at Dogfish Head to run hot CIPs on our large tanks. So, again, we try to let micro data, drive when we're going to CIP things. But once we hit that 1 month mark, we do it every time.
I guess that could be maybe make you feel a little more comfortable, Dano. And then I was curious with your project that you're working on with regards to working with your wastewater treatment plant, Dano. I was curious what that, like, how you got into those conversations with the wastewater treatment plant, and like what the process is that you're working on as far as getting them nutrients that they could use instead of having to add. I would assume lactic acid is probably what they're buying.
So the thing that they're is alum. It is, I have to look at my notes. I forget the chemical formula off the top of my head, but basically, with my interns, I kind of give them several ideas of what they can kind of go off of based on what we need in the brewery at the time, and like, go for it. And so the one intern I had is just super into wastewater treatment, and she went out and found a man named Dean, I forget his last name, Newfield, Drew Newfield, and he is a wastewater treatment plant operator out of Minnesota, where he started basically just shoveling. They run a BNR plant, biological nutrient removal. So it's a later stage. It goes aerobic to anaerobic. And at this point, you already let the wastewater treatment go through a sediment filter. It's just stabilizing and let everything fall out. So he actually just was kind of messing around with it, and they were having low carbon loads at his plant. And so he knew that spent grain had carbon in it, and so he just kind of started shoveling it in one day and just kind of dialed it in up there. And basically what it allowed for is it allowed the bacteria that they keep that be in a plant to have an alternative food source in kind of some structure as the water moved through, as the wastewater kind of moved through, and he found that he was getting lower effluent numbers than what the EPA was requiring. It was taking less time to clean the water, and he was having they were saving $5 million a year by not purchasing the alum and the other flocculants. And so right now, the Cape Fear Water Utility is who runs our water district. We're trying to see if they can set up they're getting a BNR plant in the next couple of years, and they're trying to see if there is a way that they can add to it. But we've been doing just a bunch of background research and feeding that research to them. I know the city of Chicago's wastewater is using Trub, spent grain, and something else. But because of how much water they're moving, it's not enough. So they're still buying some. And then there's another city in North Carolina called Asheboro, and they have a cereal plant in town. And basically what they're doing is they're taking the wastewater from the cereal plant, just like Kellogg's or whatever, and they're getting barrel trucks 3 days a week during the spring, summer, and fall. In the winter, it's too cold. And they're adding that just directly into the later stages of their wastewater treatment as the sugar load, and it's completely canceled out any of the chemicals that they have to buy at that time, reduce their costs tremendously. So working with Cape Fear is kind of trying to get them on board with experimenting with it, seeing if it'll work, and then what we can do to kind of help them, because they do not like front loading of our Trub and the waste that comes off the brewery. So if we can get them if we can utilize that at a later stage and kind of side stream just logistics of it. So it's a slow process, but eventually I'm very hopeful. So did that answer your question?
Yeah, and I guess that's the kind of thought that, with 9,500 plus breweries in the country, the opportunity for using the side stream materials for beneficial uses is definitely abound. So Paul and Eric, I was wondering if you could speak a little bit to, you said your initial exploration of not flipping or just flipping bright tanks was to save CO2, and that you figured out how much water you're saving. Have you done any work to figure out how much gas you're saving in not having to heat the water necessary to clean the tanks, and also how much time you're saving?
No, we've done no research into how much gas we're saving. Time savings on a typical CIP though, like I'd say a bright tank acid CIP is probably 45 minutes to 50, but a full blowdown of like an acoustic turnover is probably like 4 or 5 hours. Honestly, it's kind of done when they're done packaging. It's open for the rest of the day. But I guess the short answer is no, I haven't looked directly into how much time is being saved.
Nice.
Yeah, it's a happy benefit, but it's something that we've never had to really put on paper. So it's something we've never really looked into, but it's, path of least resistance, like, oh, this saves resources and it's faster. Of course, we're just going to keep doing that, but no, we've never taken the time to put it on paper.
One of the things that and I know that we've talked about too, and should talk about after this, we've never done we haven't committed to the benchmarking tool as much as we should have. And I know it has pushed us forward in some things, but I'll just blame it. We were doing it, and then COVID kind of came and the benchmarking kind of went out the window. But I know it's definitely something that we should do because it has helped. It did help us move forward. We didn't touch on it, but one of the things, that we do as well is we use sterile ionized air. as on our twist rinse, things like that for our can line, and that was kind of pushed forward when we were doing actually tracking our water usage. But one of the issues that we deal with here, and are maybe a little harder to separate, but we also have a large front of house, 2 kitchens, and it's hard for us, and we have 1 water line in, and it's very hard for us to separate and exactly, as we've expanded post-COVID, exactly to see how much water we're using. So it may be a little self-serving saying that, and why we haven't gone back to track.
Yeah, understood. Could definitely help you figure that one out.
Yeah, I know. As soon as that was brought up, I was like, I gotta talk to you about that again.
That's what we're here for.
Yeah.
Glad to hear it. And then Franklin, I know we're a little bit over time. Hopefully you guys don't mind staying for another minute. I was curious, Franklin, if you could speak a little bit to the logistics of capturing your rinse water and reusing it for hose down. Were you saying that it's just kind of a gravity passive type approach, or are you actually collecting it and pumping it?
So there's a lot of different ways to do it. And in one situation, it was just totally passive. The guy just dragged the hose out of the drain after he'd done his first 2 rinses and put it on the pad and used that water that was going down the drain anyway to just help rinse away any of the residue, the hops, the yeast, anything that had fallen out of the fermenter. It sounds silly, but he was busy and he was brewing at the same time. So he did a wash down step without having to stand there with the hose. And I think that's why he did it at first, but then it sort of became a thing that a lot of people moved over to. And that was, small brewery, something that was pretty easy to do. But we've also taken steps in other places to, I think some of the other panel members talked about it, collecting your wash down and putting it into, the easiest thing was a tote. Those are pretty commonly found out there in the world these days, but yeah, just about anything, a drum, and a small pump, just to get it out. Depending on what you're trying to do with that water though, at one point, we looked into putting a UV light just to make sure that we weren't spreading problems. But then we realized that there were enough issues with that, and the micro kept coming back positive on things. So we just shifted what that water was used for. So I guess the long answer is, yeah, all of them. There's different ways to do it. But you can apply it in a bunch of different fashions. And I think it's kind of a one size fits all. If it works for you, then do it. And, if it's not something you have considered, then think about it, because that's water going down the drain anyway. Find a way to, take advantage of that.
Yeah, absolutely. Thank you. Yeah, and I don't know if Crystal or Jenny or Justin, if any of you have questions for the panelists. Hearing none, I will say, I think that's all I have for you guys. I'll hand it back to Justin real quick, I think.
Yeah, I mean, I would love to say that I understood everything that was said here today, but I'm still working on my brewery engineering knowledge. But that pretty much wraps us up for today. I want to thank everybody for coming out. Really great showing and fantastic contributions. Our contact info is listed right here. You can email either of us as needed for questions you may have about the program or anything that we've discussed. The recording of today's session is going to be emailed to everybody who's registered for the event, so you'll have it if you would like to look it over again. We're also going to drop a link in the chat to Better Bev, which is the Green Craft Beverage Recognition Program that we're all a part of. Brewers can fill out a self-assessment workbook and get recognition through the program. So check out the link and contact us if you're interested in getting started in that. And like I said, thanks again for being here, and have a fantastic Tuesday.
Thank you all.
Thank you.
Y'all.
Have a good one.
You too.